Alright, so we're going to look at inverse functions. Have a look. Some of us are still going through a 3.3, but just to get us ready, I want you to take these notes regardless of where you're up to. If you need to give yourself another page, that's fine. So inverse functions are essentially a way of creating a function that is reflected around the line y equals x. So it cuts our Cartesian plane in half with our straight line there. For our inverse functions, we're trying to find the function that will replicate this function reflected around that line. I've given us a function to start with x squared plus 1, and I've drawn the inverse function there. Be aware of the notation with our inverse functions. What does that look a lot like? Yeah, so it is a power of -1, which is an inverse sign. But when you're seeing this in an exam, some kids often write this really small and it looks a little bit like a derivative. So you need to be really clear, that is a -1 there if you cannot see it. So that's what they look like. What's more important is how do we determine it? Because if you can determine what an inverse function, if you can find an inverse function and you know how to sketch all your functions, you should have no problem. So if you know how to sketch a log function, a root function, a squared function, a linear, any type of function, then the inverse functions should be very easy, providing you know how to find it. So here's an example. Now the first thing you need to do is I've given this in notation of fx equals x squared plus 1. What's the first thing I've done in this little cloud up here?
Swap x and y.
Not yet, that's the second thing, but yes, I see what you mean. But what have I replaced fx with? Y. Now you guys do that in your head. That's not something that naturally happens. I was just teaching my year 11s, which was you guys last year, and they see this and they get really confused. It's just a different way of expressing our function y equals, cool? So the first thing we do is we replace fx with y, or gx, or whatever type of function you've got. Second step, Abby?
You swap x and y.
I swap x and y. So I just swap places. And then after that, I'm simply rearranging to get y by itself again. Cool? Are we happy with that? So then I've reverse bombed us, subtracted 1 from both sides, square rooted both sides. If this was my problem and I had to state something about the domain or the range of this function, what would I have to write for my inverse function? Is there a domain limit on that inverse function? Should I keep going with this or not? This black line, should I keep going with it or stop? I should stop. Why should I stop? That's where it hits 0. So what? X can't be any less than what number?
0.
X. Y can't be any less than 0. So my range is 0 to infinity, correct? What about my x value? What's the smallest x value this function can possibly give me? Look there. What's 1? Abby's correct. How does Abby get 1? What happens when x is 0 or 0.5 or something here? What happens? What's the square root thing inside the square root? Positive or negative? Can we square root a negative number? So our range is 0 to infinity. Our domain is from 1 to infinity. Cool? So that's the sort of question they might ask you in an exam. Identify the inverse function and state any range or state its range and domain. Clear? These are the steps. Write down your formula in the form y equals, swap your x and y, rearrange to get y by itself. I've given us another example over here. Okay? Your job is to get to that. So once you've done that, you can continue on with your work there. So 3.3 or 3.4. Clear as mud?